So Le Chatelier's principle states that when stress or a change is applied to a system at equilibrium, the reaction will shift. That's the key word. Shift to one side to get back to equilibrium. So what Le Chatelier's principle talks about is you have a system, it has reached equilibrium, the rates of the forward and the reverse reaction are equal, and then something changes. That's what we call a stress. There's a change. And what will happen is that reaction will then shift, meaning it will go forwards to the right towards the products, or reverse to the left to the reactants, and it will continue to do that until equilibrium is reached again. Now, Le Chatelier's principle are rules to help us figure out which way it will shift. We're going to talk about 3 of those rules. Number 1 here is if you add a reactant or product. So if you increase the concentration of either a reactant or a product, whenever you do that, the shift will be away from the added side. It will be opposite the side that it was added. If you remove a reactant or product, if you decrease the concentration, the reaction will shift towards or to the removed side. And then finally, if you change temperature, it's a little bit more complicated, but an easy way to take care of it is you think of heat as a thing. Think of heat as a reactant or a product. And depending whether the reaction is endo or exo is where you put the heat, and then you kind of follow rules 1 and 2 to see where the change would be. So remember, endothermic, you're going to consider heat a reactant. Exothermic, you're going to consider heat as a product. So the first practice problem here, you're always going to be given an equation. The equation is going to help you determine which way it is going to shift. So right now we're starting here. We're going to do 3 changes. It says sulfur dioxide, right here, SO2, is added to the system. The key word here is added. So we're increasing the concentration of SO2. Remember, the rule is when you increase the concentration or you add to, it shifts away. So because SO2 is a product, it is going to shift away or to the left. It's going to shift towards the reactants. Here we're doing SO3, sulfur trioxide, but this time we're removing, so it's opposite. We're removing SO3. When you remove, the reaction shifts towards the removal. So again, this is going to shift left towards the reactants because you're shifting towards the removal. And finally, we're talking about O2. O2 is a product. It says O2 is added. So again, you're increasing the concentration of O2. The rule is the reaction will shift away. So again, this is going to shift left. Here, there's a little bit different. There's a key part here that you need to look at. It says the reaction is endothermic. Okay, they're going to tell you that the reaction is endo or exo. And what you need to do with that, remember, is when the reaction is endothermic, you're going to think of heat as a reactant. Remember, heat is going in endo, so it is a reactant. Then the rules are just the same. So addition of CO2 right here. When you add, it shifts away. So in this case, it's going to shift right towards the products. It's going to shift away from the CO2 side. Addition of H2O. H2O now is a product. Again, you're adding. So again, it's going to shift away to the left. Now you're going to do H2, but you're going to do removal. So you're doing opposite. H2 is taken away. It's decreased. So it's going to shift towards, which again is to the left. And then finally, an increase in temperature. So remember, heat right here is considered a reactant in an endothermic reaction. So if you're increasing the temperature, think of it as you're adding heat. You're increasing the heat. So if we think of heat as a reactant, you're increasing the concentration of that reactant. The rule is the reaction will shift away. So in this case, it's going to shift towards the right. So when you think of heat as a thing, as a reactant or product, if you increase the temp, it's going to shift away from the side of the heat. If you decrease the temp, it's going to shift towards the side of the heat. Remember, endo heat is a reactant, it's going in. Exo heat is a product, it's coming back out.